The business that we are proposing is essentially a platform where storage unit owners will be able to easily develop their websites and their data infrastructure to fully implement all that they need. And as we've gone through this semester, we've realized that there's 4 essential factors that we must keep in mind to achieve a solid plan to carry out our business operations. And they are our recovery, our security, our performance, and what resources or technologies we can use to achieve our goals. We'll begin by talking about the essential recovery options that we would implement starting our business, and also how we would scale as we continue to move forward. Essentially, we'll use the same as we implement a SQL Server database. We'll use their management system to specify how often the database is going to be backed up, the kind of backup that will occur, and also when data is removed. Starting off, we would likely do our best to use cloud resources, and that is to reduce the initial cost of starting our business. On-premises operations are much more expensive upfront than cloud, and cloud allows businesses to begin their operations as soon as the code is written, and so it's a much more manageable way of being able to start getting data and also processing and saving that data. Now, the backup recovery model actually allows us to use full backups, differential backups, and transaction backups. The full database backups are very resource intensive, and they're also going to accumulate quite a bit of cost as far as storage and also resource consumption when it's initially ran. And so for that reason, we would implement full database backup, but it would only be once a day, and that data itself would not be saved for a long duration. Only the data that would be required by law to be saved would we hold on to, and that we would even transfer to a different database, one that not only has the bare bone essentials that we must save, but also extra layers of security to prevent any leaks and hacks, because that type of data would often be very sensitive. The differential database backups would be used in between business operations, so that if there was a failure, we would be able to recover within the specified business days, though this would only happen often twice during the actual business hours for a day. So likely every 4 hours we would have this differential that would record the differences between the current status of the database and what is saved. If something happens in between a differential and the next full or an additional differential, that data would be lost unless we use transactional. And this transaction database backup would be hourly. That way we would be able to, get every single change that happened and be able to restore to that point. Now, this model means that we could have 4 hours of unsaved data that we would have to back up through transactions, and that could take a lot of time, but starting up, this would be the ideal schedule in order to save all of our data, have it somewhat manageable and recoverable if something were to happen. As we enter it into a mid-sized or large-sized operation, we would be able to scale much of these in a higher version. So instead of a full backup once a day, we could scale to twice a day, even during business hours, because we likely would be able to have resources that could manage such intensive operations. So often these kinds of tasks would happen during lunch and right after the end of the day, so 12 and 7, maybe even in the middle of the night if needed, if there is a lot of queries and a lot of actions happening, then it can be scaled according to the needs of the business, but likely 2 or 3 times for a full database backup would likely be efficient. And the data itself could be stored for much longer durations, usually month to 3 months in between that time frame, so that there's a lot less work. However, we still would have to keep certain layers of data saved and recorded for legal purposes, and so that would eventually also still end up into somewhat of a more secure layered database that wouldn't be queried very often or even needed, but kept for legal purposes. We would use differentials, often 2 hours of business operations. This would mean that if you were working a 10-hour business day, you're seeing 5 differential backups. So if something happens, there's plenty of backups throughout the day so that we can get to the closest point of failure or disaster. And of course, then we would use transactions to get back to that full point of failure. So there is no loss. This is a somewhat tedious and expensive cost, but one that is essential for business operations, where we can say how long this data is going to be saved, when we're going to back it up, how long it'll store it, when we write over our backups, and our maintenance plan will reflect our business goals in a very clean and clear way. Just to show this even more so, we will specify where these things are saved, and likely they will be saved to a very secure location on a server or even in the cloud, where we will then be able to delete anything that we don't want, that's no longer vital for our operations. And we can also specify one of our databases, many of our databases, where it saves and how often this is going to occur. That's the essence of our data recovery plan. As we go into security, things will change as we go from a small company to a large company, but 2 main ideas are what we are going to implement from the lessons that we've been taught. We're going to incorporate views, which are secure queries. They allow the individual to see only a very narrow view of the database scope, so that we can minimize data that is available to employees. When we do a select statement from this, we're only going to be able to see certain types of data. We could take out any data that's too sensitive, like passwords and the hash, anything like that, that we don't want those who run this view to see. This would likely be used most of all when you're a larger company, but we will for when we need employees to only see certain amounts of data. When we do use roles, this will change. When there's many different layers of our organization and many people have more or less clearance, this is when views become very useful. But this also allows some great optimization as well, because we can turn those views that an employee might have to review 100 times each day, and if we had 1,000 open businesses that have one employee who's running that 100 times, 1,000 with 100, we're seeing 100,000 queries of the same data. This optimizes that so that it's a readily available query that will take less on our resources. Another key thing that we will, of course, implement on top of our roles is encryption of our databases, ensuring that our database itself is encrypted. When we ever transfer it to employees and others, it'll be a no-brainer, but we can also encrypt individual columns so that we won't have to run the risk of someone accidentally seeing data that they were not supposed to see. So we can encrypt our sensitive fields so that only the administrator, the top layer, or others specified can see that. So with those two layers, we can then know that we're going to be safe from both our employees and those who might get a hold of the database itself, such as hackers. I believe that it matters just as much for a small company as a large company, and the best security practices such as safe passwords, changing passwords somewhat regularly, and allowing users to only have a certain time period between those changes will often be used. The main difference between security as we advance is just the practice of testing and ensuring that we're meeting all the specs by hiring those to truly focus on those needs. With optimization, we will use indexing to advance the queries that we need. So as we use indexing for specific queries, it significantly can reduce the resource use on our machines and our resources, so that be able to reduce the time that it takes to run a query, not only by half, but maybe even by 80%. When we start off, those kinds of decisions will be very strategic, and they'll only be on the parts of our database that are going to be used the most. Essentially, we'll identify the bottleneck and use this technique to ensure that we have high availability. But as we grow and as we expand, we will use clustered and non-clustered indexing to not only get started, but to get ahead of our competition. The example in SQL Server where we are able to see this, as we create new indexes, we can do specific non-clustered indexes, which means that to simplify indexing and the concept of it, how we will use it to improve our business and to be successful, we can think of it as the Dewey Decimal System in a library. The Dewey Decimal System uses a number like 904 to tell us where we're going to be able to go look to find that category, whether it's nonfiction or fiction. And all of the categories have already had a number designed and given to them, but this 904 will specify that we're going to actually be in a section, and then after 904 there's, let's say, like a 3.1 or 3.2 or 3 whatever that is truly the unique portion of that book. That's the same way that the index system, a clustered or non-clustered, will break down our data and simplify it so that when the computer comes through, it can go in, look at this page that has the path to that specific row of data or rows, and so then it can quickly grab all that it needs instead of looking through a whole library of books to find the one that it needed. Use of technology is pretty advanced, and that's why we would only need to use it and focus on that as we become a larger company. But we will use and implement that in our highest resource intensive operations as we begin. Cloud technologies that we can use are known as IAC, Infrastructure as Code, IaaS, Infrastructure as a Service, and virtualization tools. IAC implementations are Terraform, Ansible, Salt, Vagrant, and Chef. There's many others, but essentially what that does is it allows us to make it so that our databases are always going to be consistent and exactly the same, no matter how many times we spin up an instance of it or have to deploy a typical new database. This minimizes user error because the parameters given will create the exact same database regardless, and it is a very effective way to be able to continually implement a new server or a new database and then test, and those tests will come back the same because there's no little changes within the system itself. We'll also use infrastructure as a service such as Google Cloud Platform, Amazon Web Service, or Azure. These things are significant because they allow us to use resources that are very expensive initially if you had to buy them by yourself, but if it's essentially getting a lease or loaning out a computer that you don't have to actually buy or manage somewhere in their infrastructure away from us. And so because they implement very great security practices, we also don't have to worry as much about being hacked and being vulnerable in that way. So as we use their tools and their resources, we save money up front and are able to create our software right away. These services create much opportunity and they can be very beneficial, but they also run major risks of stacking cost, and that is one of the key things that we'll have to be aware of and very frugal on, is the kinds of servers and databases that we do run. Many have high licensing fees. We would use them sparingly and only use the services that are absolutely necessary when getting started. Many tools such as Docker and virtualization tools can be free, and we would look at the open source technologies that are useful with SQL Server, that give us the most features and abilities without making us. We also need to consider which cloud hosting between GCP, Amazon, or Azure that we would use, and often that boils down to what we need to use and then looking at what those different platforms would be able to provide and what cost it would be to actually have those run. And at first it would be very minimal and small, and so we would look at their baseline servers and see what their price would be. And with our familiarity with Google Cloud Platform, it would make a lot of sense to be able to use them getting started and to be able to run the systems that they have at a low cost. But we can also focus on just our initial needs and get our operations started. That'll be the first focus with using these technologies, is to just be able to get our actual operations going. As we evolve into a larger business, the use of these technologies would be to focus on staying ahead of competition and to optimize our services to be the most efficient and painless to the end users as possible. So through management of views and roles, through improved indexing and resource management, and through the backup recovery systems available within Microsoft SQL Server Management Studio, we're able to achieve many of these great practices to ensure that our data is available, secure, and is useful. That is the essential focus that we'll achieve by being able to develop towards the goal of starting, but having the vision in mind to use these same exact techniques to advance towards being a scalable and efficient company.